Hi, and welcome back to Section 3.2, Part 2 on how to solve quadratic equations. In this section, we're going to take a specific look at applications, solving them using the graphical solution method and validating them also using the numerical method. In this example, we are given a daily profit function that has to do with the sale of X units of product. In this case, X is the input variable, and the output variable would be the daily profit in dollars. The question is to find the levels of production and sales that give a daily profit of $1,400. The question is, what is 1,400? Is the 1,400 an input or an output? And since it's a profit in dollars, it's definitely an output, which tells us we can rewrite the function, the profit function, using the following. $1,400 is our profit output. The right side is the profit function. So we're going to let y1 equal the profit function and y2 equal the profit amount that we're looking for. Now all we have to do is go to our graphing calculator, enter these functions in, and look at the graph. But it's often hard to figure out what to set the window at. So it helps if we can find the vertex, because we know the vertex is the turning point, and if we can figure the vertex, then we can figure out the window, because I'm going to have a maximum of 9,500 on the y-axis, and on the x-axis 1,000 is my halfway point. These values are found by using our vertex formula. X-coordinate of the vertex is negative b divided by the quantity 2 times a, which gives us 1,000. Take that 1,000, substitute it into the profit function, and now we have an output. This allows us to get a really nice graph of the function, the profit function, and then the constant $1,400. We can find our points of intersection. And I encourage you to go to the Blackboard site under Section 3.2 and find the link that gives you the YouTube video on how to solve this on your graphing calculator. Another question we're asked to find is, what is the production rate that would produce a maximum profit, and what is the maximum profit? Well, you've already answered this because you're really being asked to calculate the vertex, because the vertex is where the maximums or minimums occur. We already know that the vertex is 1,000, 9,500. The trick is to interpret it correctly in the context in which we are given. So, a production rate of 1,000 units would produce a maximum profit of $9,500. Again, please go to the YouTube video link on Section 3.2 under Blackboard. In this example, we're asked to look at the percent of high school seniors who have tried marijuana modeled by this particular function, where T is the value in years after 1990 and P is the percent of high school seniors. So let's first identify the variables. The input is time in years, the output is the percent of high school seniors. And graphically, we're going to find the years after 1995, during which the percent is predicted to be 40. Well, 40 is a percent, so that's going to be my output. So I can go back to my formula. 40 is equal to the percent function. Let y1 equal 40, let y2 equal the function, and we get a graph. I look for the points of intersection on this graph, and I find that my solution, T, is approximately 17, which is 2007, and T is also 4, which is 1994, but that's not a solution we can use because we were specifically asked to find the years after 1995. We can confirm our answers numerically, and we can see that when x equals 4, we're at about 40%, and when x equals 17, we're also at about 40%. Again, please go to the Blackboard site under Section 3.2 to find the YouTube video to explain this to you. So let's look at some summaries here. We can use a graphical method and numerical methods to solve application problems. Please go on to Part 3 of Section 3.2.